Here are the notes for day 58. The title is Area Between Curves, and what we're looking at is plotting a couple functions and finding the area between them, just as the name implies. So in this case we have f of x is a cubic and g of x is a quadratic. G of x is in green and f of x is in blue, and when I go from -3 to -1, g of x is above f of x. If I take the antiderivative of g of x from -3 to -1, I'm going to get this little area between the green curve and the x-axis. And if I were to take the antiderivative of f of x, I would get this area, but it would be negative because it's below the x-axis. Well, if I take green minus blue, since the blue area is negative, you're going to get the total area here because a positive area minus a negative area produces a positive area. And then we'll do the same process between -1 and +1 because the intersections are from -1 to +1 when blue is above green. Again, antiderivative of blue would give me this positive area. Antiderivative of green is going to give me the negative area. Total area is positive minus the negative. So the setup is always top minus bottom, regardless of where the curves are. The first section, when x is -3 to -1, g of x minus f of x, because g of x is on top. Second section, when x is -1 to +1, f of x minus g of x, because the blue f of x curve is on top. Replacing the function titles with their actual functions produces this, but doing all that by hand is quite time consuming, so we're going to use our calculator. I called the blue f of x y1, the green g of x y2. In the first section, g of x is above f of x, so it's y2 minus y1. In the second section, f of x is above g of x, so it's y1 minus y2. I'm going to show you in the calculator where these numbers come from. So, on the calculator, what's happening is I've typed the numbers into y equals, okay, f of x is in y1, g of x is in y2. I've looked at the window on my picture here and said that the good x numbers would be from roughly -4 to 2, and good y numbers would be -10 to 6. So I typed those into window, -4 to 2 and -10 to 6 for x min, x max, y min, y max. I'm going to graph, make sure that my plot matches. It does look like what's on my calculator matches what I was given. So now I'm going to quit out to the home screen and have the calculator find the area between those two curves. So what I need is math. Go up to function integrate. Okay, the first section is -3 to -1, -3 up to -1. Arrow over. Now I need to put y2 minus y1. Those are in bars. Over to y bars. Choose function. I need y2 minus, same process, bars. Over to y bars. Function y1. And now I need to tell the calculator that I want to take the antiderivative with respect to x. So I put an x there. And when I press enter, I'm told that the area is 12. And that matches what I have written right here. So I'm going to repeat the same thing this time, go from -1 to 1. Since f of x is on top this time, y1 minus y2, and I should get, just as a coincidence, another area of 12. So to see how to do that, instead of retyping all that, I'm going to do second entry, which will pull up the previous command and just modify these slightly. So I'm going to arrow all the way over and say I want to go from, this number is going to be +1, this number is going to be -1, and I want to change the order. I want to do y1 minus y2. So I'll delete that first one, delete the negative, and then say minus bars, y bars, function, and this time I want y2. Enter, and we get 12. So what's happening is, by using the calculator, I save myself a lot of time, and I know that the area between these two curves totals to be 24. The brown or tan shaded area is 24. Okay, that's the first example. So you're going to practice that. Here's a second example. Same kind of a situation, except the curves cross in two places. F of x is the blue straight line, 4x plus 16. G of x is the parabola, 2x squared plus 10. They cross at -1 and at 3, for the x values. They start at -2 and they go up to 5. So you're going to need to set up 3 antiderivatives that will calculate the total of those 3 green areas. Pause the video, set up to 3 antiderivatives, and then practice using your calculator. Okay, so let's see what we got. First section, -2 to -1, g of x is on top, -2 to -1, g of x. Second section, f of x is on top, f of x minus g of x from -1 to 3. And third section, from 3 to 5 in the x values, g of x is on top. Type those 3 in your calculator, do 3 antiderivatives. Your calculator is going to give you decimal versions, but if you do math enter, it'll change them into fractions, and you get a total of 1/42, which is what the answer was. You were told the answer was. Okay, next one. This one's going to be a little bit more complicated because one of the functions we're dealing with actually isn't a function at all. The purple line, y equals x minus 1, is a straight line, but this x equals 1/2 y squared minus 3 is a sideways parabola. And we'd like to find the area between the two curves. So what we're looking for is this area inside of here. And what happens is, if we look at top minus bottom, when I look at -1, there's a switch. Left of -1, what I have is the 2 branches of the parabola. Top is the top half of the parabola, bottom is the bottom half of the parabola. Past x equals -1, I have the parabola above the straight line. So again, I've got to break it into 2 sections, but the first thing I need to do is take and solve this for y. If I'm going to take and use x values as my antiderivative value, my antiderivative variable, I'm going to go from -3 to -1 for x, and then -1 all the way over to 5 for x for the 2 sections. So -3 to -1, -1 to 5. The second part is pretty straightforward. The square root function minus the straight line function. The first half, we have a couple options. What happens is that because the 2 branches are plus and minus, positive half and negative half, when I do top minus bottom, I'm going to get square root function minus the negative square root function, which is the same thing as square root function plus square root function, or 2 times the square root function. You could also think of it as saying, I want the area under that square root function down to the x-axis, and because of symmetry, the area above the x-axis is the same as the area below the x-axis. So that's where the 2 comes from. Anyway, again, using your calculator to evaluate those 2 things, I labeled for my own benefit. I said that y1 is this, y2 is that, and then my 2 areas that get added are 2 y1s from -3 to -1, and then y1 minus y2 from -1 to 5. Get the 2 answers, add them together, total area is 18. Now what happens is we can do this in a much faster way by taking the antiderivative with respect to y. So you're going to turn your head sideways and look at the function. Imagine that you had your eye here, and you're going to look at the 2 graphs where top is to the right and bottom is to the left. If I look at it that way, then this straight line linear function is always above the curve function. And I'm saying function because if I put my eye here and travel left and right this way, these are now functions by turning my head sideways. So what I've got to do is solve both of these for x so that y is the variable I'm taking the antiderivative with respect to. This one's already solved for x. This one isn't that hard to solve for x. I'm going to get x equals y plus 1. I stored this in y3 and this in y4, but if I'm going to take the antiderivative with respect to y, I need y values on my starting and ending points, and I need to do dy. So what's happening with the y values? If you look, smaller y values are on the right and bigger y values are on the left, so you got to get used to looking kind of in a backwards way. I'm going to go from y equals -2, which is this red mark here, going up all the way to y equals 4, which is that red mark there. And in that entire y interval from -2 to 4, the purple line is above the orange line. So the top is the linear and the bottom is the quadratic. So linear minus quadratic, again, all in terms of y. I'm going to go from -2 to 4. But what I need to do is take and put this into the calculator. And even though I've written dy here, I'm going to do it in terms of x. So y3 is 1/2 x squared minus 3. Y4 is x plus 1. Going back to the home screen, I can ask it to find the antiderivative from -2 to 4 of y4 minus y3. And when I have it evaluate that, it tells me that the final solution is 18, which is again what matches what I have here is the answer. Okay. Last example, you are asked to find b such that it divides the region bounded by x equals 1, x equals 7, y equals 0, and y equals 3x minus 1 into equal spaces. So a lot of times they're not going to give you the graph, and it's going to be your job to graph it. So try and plot out those 1, 2, 3, 4 lines. See what the picture looks like. Pause the video. Okay. Hopefully your plot looks like that. All right, what we have is x equals 1 and x equals 7 produces vertical lines. 1, 7 produces vertical lines. Y equals 0 is the x-axis. And then y equals 3x minus 1 is just a y-intercept of -1 and a slope of up 3, right 1. We want to find a b location, and I'm just guessing. I don't know if it's between 4 and 5. A location where area to the left and area to the right are the same. So if I want the two areas to be the same, then the part that I don't know is the x-coordinate where I shift from one to the other. So I'm going to go from 1 to b under that straight line, and I want that to equal b to 7 under that straight line. Taking the antiderivatives, substituting in b's and 1's and b's and 7's everywhere, gives me this. Everything's even, divided by 2, quadratic formula. I get kind of a messy answer, but one that does seem pretty reasonable. At the point 5.071, the area to the left underneath that curve is the same as the area to the right under that curve. Okay? And then lastly, you're going to see a couple old review questions in your homework. So this is just a review of some stuff. First on the right, the review of the trapezoid and Simpson's rule. This delta x over 2, f of x plus 2 f of x plus 2 f of x all the way down to the end, and then the last one is back to a 1. This assumes that you have equally spaced interval, and what this is calculating is 1/2 base times height. The height is the f values, 1/2 is right here, and your base is delta x. And what is delta x? Before we did this stuff, we did the limit definition of an antiderivative. Delta x is b minus a over n. So when you see these three statements here, you have to figure out, here's your function. That's not that hard to figure out, but you got to find out your starting and your ending points. If your input for this function is -1 plus 6i over n, that means you're starting at -1. That's your a value. Okay. You're going to increase your a value by this much each time. I is the rectangle number, and 6 over n is the delta x. Well, the formula for delta x is b minus a over n. So, since we know that a is -1, b minus a -1 over n has to equal 6 over n. The n's cancel. We have +1 here. Subtract 1 from both sides. You get b is 5. Here's your function. Here's your starting point. Here's your ending point. This is the limit definition for finding the area. This is the antiderivative method for finding the area under the curve. So, quick review of a couple things from previous chapters. That's going to be a small part of your homework. Okay, that's it for day 58.